Hello, this is Derek Dean from ETAP Automation in Irvine, California, and I will be discussing the ETAP outage management software. I just want to thank everyone for attending this presentation. It's a very important product to me. So quickly, I'll just go through the agenda. I want to discuss what is the ETAP OMS and what is an OMS in general, the inspiration for the ETAP OMS, why do we do it, the solution and details, so some key aspects of the ETAP OMS, and then I'll go through a demonstration of a few key capabilities. So what is the ETAP OMS? So first of all, an OMS is an outage management system typically used to ensure that you maintain uptime, you have a good visibility of the system, and if there are any customers that lose power in a distribution electrical system, that power is brought back up as quickly as possible to as many customers as possible. So what ETAP has provided is a complete enterprise outage management system leveraging the ETAP digital twin. The very most important fundamental building block of everything ETAP is that digital twin, which gives us so much knowledge and insight into how the system should behave under optimal conditions, then we know how it will behave under normal conditions. It's an advanced digital twin based fault location, isolation, and service restoration solution, meaning that we can identify where the fault is with minimal inputs from the field and then provide a switch plan for which switches to open and to close in order to partially restore as many customers as possible, and then eventually, once the fault is cleared, to restore all the customers. There is a work order management and planning tool built in, crew management, integration with a suite of ETAP products, and third-party tools. One thing that's always critical with any OMS is there's a lot of different tools that need to be communicated with. And so we've built drivers in order to do that. Some of the inspiration for the ETAP OTS or OMS is some of the things that are missing. The typical OMS lacks tight integration with the planning tools. So on the engineering side, as you're making adjustments to your network, adding new feeders, new interconnections, in the process of validating that and deploying it in the field, and then bringing from the planning tool to the OMS, it can leave for some information loss. It's rework, and it's not validated. There's no great tool to validate what's in your OMS database if all it's being used for is OMS. Lack of full understanding how the system responds to certain events. So this goes back to the digital twin concept. A typical OMS only has so much information. It doesn't care about all the impedances typically, or all the information that exists in a model that's used for planning. Let's say your fuse ratings. So there's a lot of information there that we can take advantage of on our OMS because we already have the entire electrical model. Lack of optimizations for isolation and restoration steps. So in addition to our ADMS package, which has optimizations for feeder balancing and switching optimizations, we can also take those same optimizations when we're looking into isolation and restoration steps. So we can make sure if there's multiple possible restoration or partial restoration steps, we can use the optimal one. Lack of validation in switching plans. So this is very important. So if you need to, let's say, take a transformer out of commission and you need to create a switch plan, you typically want to validate that switch plan is going to be successful. You're not going to take down the system or ground an energized bus or anything like that. So typical OMS doesn't have that capability. I mean, the big thing here is an overall lack of intelligence. The ETAP OMS solution. So the key here is the model-based solution. It's the same model for design, planning, and operations. You validate your model updates before bringing to operation. So you actually make your changes in the model, but before deploying to operation, you validate those changes. And so you know you have the confidence that the model that you're using is correct. leverage planning and optimization engines during operations. So we have all these engines, these calculations engines, unbalanced load flow, short circuits, switching optimizations, volt-var optimizations. All of those engines can be leveraged in operation time. So you can do predictive simulation, what if analysis, you can do optimizations. All of that is just using the tools that we already have on the planning side. It's just being brought in onto the real-time side. And of course, handling of DERs, distributed energy resources, are becoming more and more critical, and ETAP has the libraries and the capabilities to be able to handle those. And so those are automatically part of the solution with our OMS. So this slide is just reiterating this concept of the model to operate. So we go from modeling to analyze to monitoring to operate to optimize. So it's one common model for the entire solution, and you're constantly keeping it updated and using it for operations. The fault location, isolation, and service restoration. So it's digital twin based calculations for FLISR. So it's using that digital twin to be able to calculate the fault location. Utilize information from the model to refine your prediction. So the more information you have, the more refined your predicted fault location will be. Some of the measurements we use, and of course we don't have to use all of these. So from the substations, we can use the relay information, bringing in the circuit breaker statuses, the power measurements from the relays, your reclosers, and then your power meter information. On the line side, fault indicators, RMUs, transformer monitoring units. So if you have on the primary to secondary network those distribution transformers, if there's transformer monitoring units where we can get the megawatts, megawars voltage, we can use that as part of our fault location calculation. Customer information, AMI, MDM, customer care centers, all of that information we can bring in. So if there's a customer call that comes in, or if the AMI detects a last gasp of an outage, we can bring that in and use that to help correlate where the fault is located. And then, of course, disturbance records. So the real key heart of that FLISR is that advanced calculation based off of the ComTrade file to be able to determine exactly where the fault is located. The reporting side of the OMS solution, we have an automatic calculation and reporting of reliability indices, the SAIDI, CAIDI, etc. We generate shift reports, so every 8 hours or whatever your shift time is, 12 hours, you can customize it so you create a shift report so you know exactly what happened on the change of the shift, what alarms were generated, what alarms were inhibited, what service tags were generated, what any anomalies that happened. All of that information is available to be calculated and provided every X amount of hours. And of course, the standard energy reports. So if you have want to know your total consumption, etc., for a period of time. Planning and scheduling. It's a powerful tool for planning and scheduling activities. So we have our switch order management tool. We have predictive simulation where you can create a switch plan and validate that switch plan in ETAP using the studies, using the load flows, and validate that switch plan. Manage all planned and unplanned work in one integrated platform, and customizable workflows. Crew management, personnel and crew definitions, crew shift and capabilities are definable here. Asset allocation, so what kind of assets what kind of spares does each crew have, what are their expertise, and then you can schedule your crew, create standard schedules, and then of course we can have AVL, automatic vehicle location integration, so you can know where your crew is at any time. And then integration is integrating the OMS with all these other tools. So for instance, on the ETAP side, we can integrate with the ETAP design, so the planning tools. We can integrate with the ADMS, the EOTS, which is an operator training simulator, so you can run scenarios on your OMS against the operator training simulator. Forecasting and load shedding, all of that we have integration with already. And then on the third-party side, we have communications drivers. We have AMI, MDI integration, AVL, customer care center. If there's microgrid or PPC controllers, we can communicate to those devices. If you have customer portals, weather interfaces, CIS and billing, all of that, we can bring in that information in order to make a more robust solution for your OMS. So now I'm going to go through a quick demonstration. I'd like to start by discussing the customer information management page here. So here's where we bring in a list of all of the customers in the system coming from the billing information, the customer care center, and the ETAP model and the AMI. So we actually link all these different pieces of information together and provide one cohesive database of all customers. So here I have an account ID, perhaps from the billing system. The ETAP ID is the name of the actual load in the ETAP model. The meter ID, which is coming from the AMI, and we can show a number of critical pieces of information. So what's the service status? Are they in an outage right now? What's the billing status? Are they overdue, canceled? Now this can be defined here in our software, or it can come in from the billing software. How many complaints have they provided? So how many customer calls for outages? How many outages have they experienced recently? What's the last incident they've been associated with? So we have a wealth of information, and also what feeder are they currently on. As they maybe there's a partial restoration, they can move to a different feeder. So we have that information here for you. And then of course the street address, all the other information associated with it, the owner, phone number, email, all of that information. If we have it, we can bring it in. And next I'm going to move on to the crew management. And here we can actually provide information about your employees and the crews, the groups of employees that work together. So here we have in the employee section, here's my employees with their mobile, email, etc., and their job titles. And then for each crew, you can define the personnel in that crew here. And you can also define their classification. So is there a certain area that they work typically? What's their expertise? What's their vehicle that they use? What other equipment do they have? Do they have spares? Do they have PPE, etc.? So all that can be defined here. And then additionally, you can actually create shifts for each crew where you can see define based on a pattern or ad hoc. This crew works on this day from this time to this time, etc. So here you can see when I go through my month view, you can see all the different crews that are working for each period of time. I can go to an individual day and see who's working when. It can be very helpful for scheduling out. And we use all this information in our switch order and work order management solution. So one example I'd like to show very quickly is a maintenance request on a transformer. So this is a planned maintenance by myself for a transformer, and actually it's left over from a previous event, but I can pull it up here. So if I can get a list of all of my equipment, and I can select this transformer here, and I can say maintenance required for a transformer. Please de-energize and ground the transformer. So me as just someone that is putting in the request. I'm not approving anything. I'm just putting in the request. When I hit generate request, this will actually send off the request to the correct individual to approve it. So let me move this over. I've selected this this work order. Here are all the details I inserted previously. Now I can go and review it. I can say, well, I'm ready to assign a crew. I think it's a little early for that. I can deny this request. I can send for approval without a switching sequence. But since we need to de-energize a portion of the network, we need to request a switching sequence. Here, so I've requested a switching sequence, which sends out an email to the engineer who would be putting together the switching sequence, saying that here you have a new work order, please proceed with creating a switching sequence. And at this point, they will open up ETAP and go to sys simulator presentation. So not look at real-time data, but go into a study presentation and use the switching sequence management module. Here I'm going to go to that transformer here, so you can see this is the transformer, and we want to de-energize this transformer. So I open up the builder and create a new switching sequence, and I'm going to open or close each of these breakers, and so now it is grounded. When I hit OK, and I go to my run switching sequence page, The first thing I want to do is hit Get Online Data. So I'll use the actual operating conditions in the field right now, and then I want to run the scenario. So I'm going to expand this a little bit and say Auto Start. So you can see that I made an obvious mistake here. Ground switch number 1 is grounding. It's an invalid action. It's because I'm grounding an energized network. So if I go back to here and look at my switch plan, my first step was to open this breaker, or open this breaker, and then to close my ground switch. But unfortunately, I'm already energized from across the other feeder, and so I'm grounding an energized bus. So the way to resolve that is to take this last step, which is to open the secondary breaker and make it my second step. And I'm going to not group anything and hit OK. Now I'm going to run that switch plan again. Auto start, and you can see that there's no errors. I've completed each step. Now there's no alerts, so this is a valid scenario, and I can assign it to that switch order. So if I go to my switching orders, I can select that switch plan, and I can hit OK here and export it out to the switch plan. And now it's ready, validated, and you have the assurance that this switch plan will be successful. So again, I've created the switch plan in ETAP, and then validated it in ETAP, and then pushed it out to my switch order management tool here, where you can see each of my steps, and you can go and execute it when the time comes. Next, I'm going to go through an unplanned outage. So I'm going to go to my sysmonitor presentation, so I'm online, zoom out a little bit. And one key piece here is I have a feeder here, and I'm just going to show it, trace my feeder. This feeder here, it starts up here, and it's going to go down here and then branch off into 3 different laterals. But there's fault indicators at some key locations, one right here, some up in here. And so our prediction will update based on which fault indicators see the fault. So first what I'm going to do is trip my feeder breaker. So you should see it goes to de-energize. That's why it goes to black. And we should predict this top section here once the calculation comes in. So we're predicting that the fault is somewhere up here, and that is because we don't have any inputs from the fault indicators. We purposefully made this scenario a little confusing so you can see how the calculation updates as time goes on. So now I'm going to inject this fault indicator seeing it, the fault, but these fault indicators up here don't see the fault. So now what we should see is this section here should be the prediction zone. So as we can see here, we are predicting that the fault is somewhere here. We still have de-energized the entire network, but we're predicting that the fault is somewhere in here based on the fault indicators. Now is where I'll go into my OMS viewer and look at my estimation. So here you can see some of the information. I have 78 customers that are outed, experiencing the outage. The feeder is the CHSD feeder. It's on the estimated that it's on the primary distribution network. And you can even see, if I move all the way to the right, the type of fault from the fault indicator. This looks like an earth fault. So now what I'm going to do is, well, the first thing I want to do is create an SO to locate the fault. So we need to dispatch a crew to go and find the fault. So I've created a switching order. That's what an SO is. And I'm going to go back to here, refresh this list, and I have here a new outage, unplanned from the OMS. And if I look in this section, I can see a locate outage faulted component tab here. So here I can assign a crew. I'm going to assign a crew right now. And one key thing when I assign the crew is you can see how much time is available left for that crew. So that can be very helpful. But then you can go and look at a map of where the fault is located, or report the faulted component. So now, let's say you've been dispatched, you've gone and looked for the faulted component, you found it based on the prediction zone that ETAP has provided, and now you can go and select. I'm just going to select this section here, and say this is where the fault is, tree fallen. And now when I go into my OMS, or into ETAP, sorry, can now see that we are no longer looking at a prediction zone, but we have a confirmed fault location here. Now, what we can do with that is our isolation and service restoration algorithms can start kicking in. So behind the scenes, we're calculating the isolation service restorations. Meanwhile, we can see that the status is now confirmed. Crew 2 is associated with it. Here's my switch order that is associated with it. Now I can go to my ISR tab here and see, oh, here's my switch order that's been calculated. And here you can see the feeder capacity that the customers are being restored to, and all the other information, and you know that it's safe to actually restore these customers. So then I can export this to my switching order and go back to my switching order and go to my SSM tab, and here I can see my isolation step here and my restoration step here. Then you can go through and execute each of those steps to restore as many customers as possible. So I want to thank you for giving me the opportunity, and I'm going to open it up for some questions. One question I have here is, what industrial communications protocols do you support? So natively we support Modbus, DNP, IEC61850, IEC104, ICCP, OPC-DA, OPC-UA. Now, there's many different converters from OPC-UA or OPC-DA to other protocols. So I guess the long story short is I haven't found a project where we haven't been able to get a converter. One question is, how do you typically get the vehicle locations? So we don't have our own hardware. We'll use third-party solutions and then integrate with them. Sometimes it's just reading a SQL database over the network. Sometimes it's sending REST API calls. There's other solutions, CSV files that have been dropped into a folder as well. Can the solution automatically pass the reliability indices to someone else, say a third-party entity? Yes, we can actually, as part of our reporting tool, provide in CSV format critical data, so the SID, KID, all those different statistics. But additionally, we can send out other historical data, so maybe time series data via CSV, events and alerts, that we can also send all that information out. So if you have, say, like a forecasting tool or a regulatory board that you need to send the information to, we can automatically send that information. So I believe I've run out of time here. So if you have any more questions or want to follow up on anything specifically, my name is Derek Dean. You can give me an email at derek.dean@etap.com, and I appreciate your time. Thank you.